All right, welcome back. This is ET120, Engineering Problem Solving, and the do's and don'ts of dimensioning. So I've reworked this presentation a little bit to kind of go through dimensioning our detailed drawings. But I'm going to use a PowerPoint and there'll be kind of less of me. So let's get to it. All right, do's and don'ts of dimensioning. I don't know about the sound effects. So the size is shape, the location, and tolerance of an object, and all features on an object must be communicated for the manufacture or construction of the object. Now, I'm not going to spend a lot of time in tolerancing, but there really should be a tolerance on every drawing. When you get them in industry, they will have that. I am going to see if I can turn the sound effect off. Just don't know about that. Anyway, our whole goal is clarity. Each feature in the object needs to be dimensioned only once. So don't repeat dimensions on each view, only provide it once. The dimension is placed on the most descriptive view of the feature. I'll show you some examples of that. Now, here's an example of an engineering drawing that has a bunch of rules broken. So they have placed dimensions on the object. We want to try and keep dimensions off of the object. They're doing some clustering. This is good. They're doing some tolerancing. That's good. But this is not a horrible drawing. It's just very, very busy. So we want clarity and simplicity. Same with this one. All right. A dimension is the number. So when we talk about a dimension, it's the number, the numerical value defining the size, shape, location of a feature. So it's the text, right? 3 millimeters or 1/8 of an inch. The line spacing between a 16th. I'll show you what that means. We're going to use different units. We could be in feet. We could be in millimeters. We could be in degrees, or we could be in radians. So all of that needs to be specified on the drawing if you're going to have a completed technical engineering drawing. There should be a note, and that note should say something to the effect of, unless otherwise specified, all dimensions are in millimeters or inches. Therefore, you don't have to put the unit down on each dimension. So that can be in the title block or just a note in a specific area. We're not going to do dual dimensioning. So that's kind of above the scope. We are just going to do basic and reference dimensions. So that's this kind of dimensioning, right? So this is what we've talked about. These dimensions are well done. There is no break in the extension line. I'll talk about that in a second. Leaders travel through the geometric center. So that's actually a little off. If this line continued, it should go through the center of whatever it's marking. Okay, should definitely have a shoulder. The spacing between the object and the dimension lines, that's a consistent 3/8 of an inch. Consistent is what I worry about. I don't, if it's a 1/2 inch or a 1/4 inch, that's up to you. But that it's consistent all the way around the drawing, like that spacing from the object to the first dimension is the same all the way around, right? There's no break in the extension lines. All of the arrowheads touch the extension lines. This is a problem, not good technique at all right here. So we'll go over a few of those kind of things. But just an example of good dimensioning. It's clean. The dimensions are thinner than the visible lines. The visible lines are thick. So this is done very nicely. It can be read easily and it's organized. We've talked about all of these, right? The dimension line holds the dimension. The extension line extends to the object, and then there's a visible gap. So extends to the object, right? And then there's a visible gap. extends to the object. Yeah. All right. If you're going to use diameter, that's the diameter symbol. If you're going to use radius, we use an R for radius. We typically, for mechanical, place the number inside the dimension line, inside the dimension. Yeah, if it doesn't fit, we pop it out. And if it still doesn't fit, we can move the arrowheads out. They should still touch the extension line. Some of you are not touching your arrowheads to your extension line. Kind of bad technique. So let's work on that for the final. Spacing. Spacing is typically 3/8 of an inch from here to here. And then it's typically a quarter. So first dimension line, 3/8 of an inch. Next dimension line, 1/4 of an inch. You can measure that if you want. I really just look for consistency. All right. Here's some guidelines. Number one, every dimension must have an associated tolerance. We haven't talked about tolerancing. So I'm not going to throw that out here right before the final, but you can just put a general tolerance down in the title block typically, or look for the general tolerance down in the title block. A lot of times each dimension is not toleranced, but there is a general tolerance for the drawing like this right down here. Sometimes you'll see it up in the dimension or a range. It can be 20.2 to 18.8, but most of the time we're just going to place it right down in the title block or a general note. Dimensions on the view that best describes that feature. So the whole is best described in this view. That's why it's dimensioned here. Not in this view. It's hidden in this view. It's a terrible spot to dimension the whole, right? This geometry is nice and clear on the profile, so all of these are really good, right? Not up here. You could put this one up here, but it's not as descriptive. So think about where's the most descriptive place to place the dimension. This is not great over here, marking the center of a circle that goes through a hidden thing. It's not good. It'd be much better over here where I see the circle, right? This 20, much better over here where I see that shoulder. We never dimension to a hidden line, so this is totally incorrect. So all of these, there are better spots for these dimensions. And it's where you see the profile or the object. More examples. Both of these better over here. All right, maintain your minimum spacing. Maintain a visible gap between the extension lines and the features. So we need this gap. It's important. Gap, gap, gap. All of that's good. No gap if you're crossing over the visible lines to get to the object. No gap. Here they're using a center line as an extension line. That's perfectly appropriate. This spacing is a little big. It's a little wonky. If you're talking about the metric system, not less than 10, not less than 6. So it's okay. Do not place dimensions within the view. Don't put them in here. Get them off of the view, Okay. So if you can, sometimes you're stuck and you have to squeeze something in. That's fine. You got 10 dimensions around this thing and you have to stick one in here. That's legit. But this, that's a train wreck. All right. Unless otherwise specified, angles are assumed to be 90 degrees. So that you do not have to note. Dimension to visible lines. Some of you are breaking this rule. We cannot dimension to hidden geometry. That's not a standard that we follow. So we dimension to visible geometries. So this is inappropriate, but if we show it in section view form, then we can dimension it because it's all visible. So Get creative, stay away from those hidden lines. Use appropriate symbols. So here's some examples of symbols that we want to use. If you see them, they're in your book, you can look them up because it's not always clear what they mean if you haven't used them a lot. So R for radius is very common. And then this is the diameter symbol right here. This is spherical diameter, which we haven't really talked about, but those two symbols we've used a lot, and you will see the counterbore symbol and you will see the depth symbol quite a bit. Countersink is called it. So yeah. And here's just some examples of where they show up, right? If you have a couple holes, then we can call out the first hole right here. Will be the larger diameter, the 24, and then that would be the depth, 8.8. So here. So all of this is pretty well called out just in this statement. So you'll see this quite a bit on different drawings. We haven't got into the symbology of graphics yet, but thought I'd include it in this conversation. All right. Cluster your drawing, cluster your dimensions. This is great clustering. These are lined up nicely. Everything's easy to see as far as the dimensioning goes. This is just kind of wonky, right? Just kind of all over the place, some down here, some over here, some high and low, not good. This is much preferred clustering dimensions. No gaps in your extension lines. This is good. This is not good, right? No gaps. You can use a center line as your extension line. That's very good, right? But no gap there. Just some more information about what we cross and what we don't. Extension lines can cross. That's great. Some of you did this in the last exercise where you sent an extension line straight through a dimension line. That's not good. Can't do it. That breaks a rule, right? And then keep it off the object. This is wonderful. Says no, but this is actually, oh, the extension lines should go the whole distance. That's what's wrong with this. Extension line all the way to it and then the gap like this. All right, very good. I hope that helps, and hope you review it before the final and clean up that dimensioning a little bit.